In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet operations with complex numbers. Our direction for this first set is to simplify. Now, before we really dive in, let's quickly talk about a complex number. Complex numbers are generally in the form of a plus b times I, where a is the real part of the number and b represents that imaginary part. I is that imaginary unit where I squared equals -1. So another way to think of I is as the square root of -1. That is that imaginary unit. So when we dive into number 1, we can see that we have two different complex numbers. Neither of them have a real part, but both have an imaginary part. This one is like 1i plus we have 6i. And an easy way to think about operations with these complex numbers is to use I as a variable. If we think of I as a variable, we know that I represents that square root of -1, but we can add it the same way we would a variable. So let's dive into number 1. Simplifying this operation with complex numbers, I plus 6i, well, that's going to be 7i. Moving on to number 2, we have 3 plus 4 plus 6i. We can add the real parts together. 3 plus 4 is equal to 7, and we're going to leave the imaginary part as is. There's no way we can combine this imaginary part, so we're going to leave this as 7 plus 6i. And that's our solution for number 2. So again, we can combine the imaginary parts and we can combine the real parts together through these operations. Number 3, 3i plus I, that's going to give us 4i. For number 4, we have -8i minus 7i. So starting with the negative and going further into the negatives, that's going to be a total of -15i. For number 5, we have two separate real parts, this -1 and this 4 that's subtracted. So starting with that, -1 minus 4 is going to give us a -5. Next, I'll combine those imaginary parts. So -8i minus I, that's going to be a -9i. So minus 9i. And that is our complex number for number 5. Combining all my real parts, I have 7, 4, and 4. 7 plus 4 plus 4 is going to result in a positive 15. And I just have this one single imaginary part, so I'm just adding I. 15 plus I is my complex number for number 6. For number 7, -3 plus 6i minus -5 minus 3i minus 8i. And in this instance, we have parentheses. So we need to make sure we distribute this subtraction or distribute the negative throughout. So rewriting this, removing those parentheses, I'm going to have -3 plus 6i minus a -5, so that's going to be plus 5, and then minus a -3i, so that's going to be plus 3i. And then finally subtracting 8i. Now I'm going to be able to combine my real parts, -3 and 5, and then my imaginary parts, 6i, 3i, and a -8i. -3 plus 5 results in a positive 2, and I'm going to be adding that to 6i plus 3i, which is 9i, minus 8i is going to be 1i. So we have 2 plus I as our solution in number 7. For number 8, we're going to combine 3, 8, and then subtract 7. So 3 plus 8 is 11, minus 7 is going to give us a positive 4. And that's going to be added to, looking at our imaginary parts, we have a 3i minus 2i, that's going to be a positive 1i. So we have 4 plus I for our solution in number 8. In number 9, just like up above in number 7, order of operations matters. So I'm going to distribute this 4i to the -2 and to this 8i that's subtracted. So rewriting this, I'm going to have 4i times -2 minus, leaving that subtraction in between, 4i times 8i. Now multiplying 4i times a negative 2, again, treating that i similar to a variable, we have 4 times negative 2, that's going to be a negative 8, so we have negative 8i. And we're subtracting 4i times 8i. So 4 times 8 is 32, and then I times I is I squared. But what did we say up in the beginning of this worksheet? What is I squared? I squared is equal to negative 1. So replacing I squared with negative 1, we now have negative 8i minus 32 times a negative 1. So multiplying 4i to this complex number, when we get that I squared, it actually becomes a real number. So we have negative 8i minus 32 times negative 1. That's minus a negative 32, so plus 32. So this is 32 minus 8i as our simplified problem in number 9. Moving on to number 10, we have 5i times a negative I. So I'm going to rewrite this as negative 5 times I squared. What is I squared? I squared is negative 1. So this is equal to negative 5 times negative 1, which is equal to a positive 5. There we have it. Multiplying those imaginary parts together resulted in a real number. In number 11, we have 5i times a negative 2i. Starting with combining, since everything's multiplied together, combining 5 times negative 2, that's going to result in a negative 10. And then I have I times I times I, so that's I cubed. But I know for a fact I can simplify I cubed down a bit, because I cubed can be rewritten as I squared times I. So I have a negative 10 times I squared times I. What is I squared? I squared is negative 1. So this is equal to negative 10 times negative 1 times I. So number 11 simplifies down to a positive 10i. So as stated before, we're going to treat I like a variable. But we need to remember that we actually know the value for I. I squared equals negative 1. So in order to simplify this, if there's an I squared present, we're going to simplify it down to a negative 1. We did not want to leave it as an I cubed because that could be simplified further. So just remember this as we're moving through this worksheet. For number 12, negative 4i times 5i, negative 4 times 5 is negative 20, and I times I is I squared. And what is I squared? That's a negative 1. So we have negative 20 times negative 1. That results in a positive 20 for number 12. Moving on to number 13, we have the complex number negative 2 minus I, and then 4 plus I. Notice that these are in parentheses, so we're going to need to do a little bit of distribution, a little bit of foiling. So I'm going to start with my first, then multiply my outside, inside, and then finally last to expand out these binomials. So I'm going to have negative 2 times 4 plus negative 2 times I plus negative I times 4 plus negative I times I. So simplifying this down, negative 2 times 4 is a negative 8, and we're going to be adding that to a negative 2i, and adding that to a negative 4i, and then finally, negative I times I is negative 1 times I squared. And I squared is negative 1, so we're adding the opposite of negative 1, which is a positive 1. Continuing to simplify this, we can combine negative 8 with a positive 1 to give us a negative 7, and we can combine negative 2i with negative 4i, and that would result in a negative 6i. So we have negative 7 minus 6i as our solution for number 13. For number 14, what are we going to do? We're going to need to distribute or FOIL again. So first, outside, inside, and then last. We have 7 times a negative 8, which results in a negative 56. we're going to add that to 7 times 3i, which is going to be 21i, and that gets added to negative 6i times negative 8, which is going to be a positive 48i, and then negative 6i times 3i is going to be negative 6 times 3, which is a negative 18, and then I times I is I squared. So simplifying this down, we can combine 21i and 48i together. So we have negative 56 plus sums to be 69i, and then we're subtracting 18 times I squared, 18 times the negative 1, since I squared is negative 1. So as opposed to subtracting a negative 18, we'll add a positive 18. Simplifying this one more step, combining negative 56 with that positive 18 we just got, that's going to give us a negative 38 plus 69i. That's our solution for number 14. Continuing on to number 15, we have 7i times 3i times the quantity, or this complex number, negative 8 minus 6i. What we want to do is simplify this down. And we can combine this multiplication outside of the parentheses at the start. So if I have 7i times 3i, that's going to be 21i squared. And 21i squared is 21 times negative 1. So this 7i times 3i results in a negative 21. So I'm going to write this as negative 21 times negative 8 minus 6i. Now I'm going to distribute this negative 21 into the negative 8 and to the 6i that's subtracted. So negative 21 times 8 is going to result in a positive 168. Calculating out negative 21 times negative 6 would be that positive 126. So 168 plus 126i is our solution for number 15. Moving on to number 16, we have 4 minus 5i times 4 plus I. What are we going to do? We need to expand out these binomials. First, outside, inside, last. FOIL. So 4 times 4 is 16. That's going to get added to 4 times I, so 4i, added with negative 5i times 4. So I'm going to write this as subtracting 20i. And then finally we're adding negative 5i times I, which I'll write as a minus 5i squared. And remember, what is I squared? Again, it's a negative 1. Remember that when dealing with complex numbers, that I squared is equal to negative 1. So we're subtracting 5 times negative 1. Subtracting a negative 5 is the same as adding a positive 5. So 16 plus 5 is going to result in 21, and 4i minus 20i is going to give me a negative 16i. So 21 minus 16i is my solution for number 16. And it's also the last problem on this first page of this worksheet. If you've been finding this video helpful so far, please feel free to let me know by clicking that thumbs up button. But for now, let's continue on to that second page. Number 17, we're going to continue to expand these binomials in order to simplify these numbers. So right now, we're basically just multiplying two complex numbers together, where we have real and imaginary parts for each. Thus, we need to distribute throughout. So 2 times negative 6 is a negative 12. 2 times 4i is going to be a positive 8i. Negative 4i times a negative 6 is going to result in a positive 24i. And then lastly, negative 4i times 4i is going to be, well, subtracting a 16i squared. This 16i squared we can rewrite as 16 times negative 1, which is negative 16. So subtracting a negative 16 is the same as adding a positive 16. Negative 12 plus 16 is a positive 4, and we're adding that to 8i plus 24i, which results in 32i. So our complex number in number 17 is 4 plus 32i. For number 18, negative 3 times negative 6 is a positive 18. negative 3 times negative 8i is a positive 24i, plus 2i times negative 6 is a negative 12i, plus, and then 2i times negative 8i is going to be subtracting 16i squared. But again, what is I squared? That's equal to negative 1. So negative 1 times 16 is a negative 16, and if that's subtracted, that's the same as adding 16. So if we have 16 plus 18, that's a positive 34, and we're adding that to 24i minus 12i, which is a positive 12i. 34 plus 12i is our solution in number 18. For number 19, again, FOIL. First, outside, inside, last. Treating that I like we would a variable since there's different parts to these complex numbers. So 8 times negative 4 is going to be negative 32. 8 times negative 4i is going to be minus 32i. Negative 6 times negative 4 is going to be plus 24i. And then negative 6i times a negative 4i is going to be plus a 24i squared. I squared, what does that equal? It equals negative 1. So we have negative 1 times 24, which is a negative 24. Negative 32 plus negative 24 is going to result in a negative 56. And then combining negative 32i with 24i, adding those together, that's going to be a negative 8i. So negative 56 minus 8i is our complex number in number 19. For number 20, we have 1 minus 7i squared. What are we going to do? Well, I can tell you what we're not going to do. We're not going to distribute this squared in. That is not how we deal with exponents when there is subtraction or addition within those parentheses. What we're going to do is we're going to write this out and FOIL it. So 1 minus 7i times 1 minus 7i, that is 1 minus 7i squared. 1 times 1 is 1, and then 1 times negative 7i is minus 7i, and then negative 7i times 1 is minus 7i, and then we're finally going to do negative 7i times a negative 7i. Negative 7 times negative 7 is a positive 49, and that's multiplied by I squared. What is I squared? I squared is negative 1, so 49 times I squared is a negative 49. So 1 minus 49 is going to be negative 48, and when combining negative 7i and another negative 7i, that's going to be minus 14i. So negative 48 minus 14i is our solution to number 20. For this problem, we have 6 times negative 7 plus 6i times negative 4 plus 2i. So we have this real number multiplied by two separate complex numbers. One way we can deal with this is we can distribute the 6 in at the start or work on FOILing these out and then multiply by 6. What I'm going to do is I'm just going to go ahead and multiply this first complex number by 6. So multiplying both the real and imaginary part by 6, we're going to have negative 42 plus 36i. Now I'm going to take that and multiply it by negative 4 plus 2i. Negative 42 times a negative 4 is going to result in a positive 168. Then negative 42 times positive 2i is going to be a negative 84i. Then 36i times negative 4 is going to be another negative, and that's going to be 144i. And then lastly, 36i times 2i, 36 times 2 is a positive 72, and that gets multiplied by I squared. 72 times I squared is 72 times negative 1, which is negative 72. So if we have 168 and we're subtracting 72, that's going to leave us with 96. So this simplifies down to 96 minus, if we have a negative 84 and we're subtracting 144, that's going to be a negative 228i. So 96 minus 228i is our solution in number 21. Moving on to number 22, what we're doing here is we're multiplying 3 separate complex numbers. So we're going to have to expand out this entire problem. And how I'm going to start this problem is by multiplying the first 2 binomials together. And then once I do that, then I'll multiply those terms, that new complex number, to our third and final complex number, 7 plus 8i. So doing this, -2 times -4 is a positive 8. -2 times a -3i is going to be a positive 6i. -2i times -4 is going to be a positive 8i. And then finally, -2i times -3i is going to be a positive 6i squared. And this entire quantity, which is going to result in a complex number, is going to be multiplied by 7 plus 8i. So 8 plus 6 times i squared is a -6, since 6 times i squared is 6 times -1. So 8 plus -6, or 8 minus 6, is a positive 2. And we're adding that to 6i plus 8i, which is 14i. And that gets multiplied by 7 plus 8i. So now we're just going to multiply these 2 complex numbers together. 2 times 7 is going to give us 14. We add that to 2 times 8i, which is 16i, plus 14i times 7 is going to be 98i. And then lastly, 14i times 8i, that's going to be a positive 112i squared. What is this number? 112 times I squared? Well, if I squared equals -1, this is going to result in a -112. So 14 minus 112 is a -98, and then we're adding that to 16 plus 98, which is a positive 114, and that's all multiplied with I. -98 plus 114i. That's our solution for number 22. For number 23, we have 5i plus 7i times I. Well, 7i times I, remembering those order of operations, we're going to compute this first. So we have 5i plus 7 times I is 7 times I squared. And what is I squared? That's a -1. So we have 5i plus 7 times -1. So this simplifies down to the complex number -7 plus 5i. In number 24, we have 6i cubed. The nice thing about this is because 6 is multiplied by I, we can just distribute that cubed to both our coefficient and to the I as well. We can distribute that exponent when there's multiplication, but we cannot do it when there's addition or subtraction between our numbers. So 6 cubed times I cubed, well, 6 times 6 is 36, times another 6 is going to be 216. And what exactly is I cubed? Well, we don't know what I cubed is, but we know what I squared is. So let's rewrite I cubed as I squared times I. I squared, we know, is -1. So this is going to be equal to 216 times -1 times I, which is -216i. That's our solution for number 24. For number 25, we're multiplying 6i with -4i plus 8. If there was parentheses around -4i plus 8, I would have to distribute this 6i, but there's not, so we can just work with that multiplication at the start. 6 times -4 is -24, and that gets multiplied by I times I, which is I squared. And then we're adding 8. -24 times I squared is -24 times, what is I squared? -1. And then adding 8. That's going to result in a positive 24 plus 8, which is a positive 32. So 32 is our solution in number 25. For number 26, this is the case where we definitely need to distribute. -6 times 4 is -24, and then -6 times 6i is a -36i, but that's subtracted, so we're going to add a positive 36i. And there we have it. Nothing else to simplify down. That's our answer in number 26. In number 27, we have 8 minus 3i, that quantity squared. Remember, what we're not going to do is we're not going to distribute that 2 through. We are going to write this out and expand those complex numbers by multiplying each of their parts together. So 8 minus 3i times 8 minus 3i, that is 8 minus 3i squared. So 8 times 8 is going to give us 64. 8 times negative 3i is a negative 24i. Negative 3i times 8 is a negative 24i. And then negative 3i times negative 3i is a positive 9i squared. But remember, this positive 9i squared is really a negative 9, since I squared is negative 1, and that's multiplied by 9. 64 minus 9 is 55. So we have 55 minus 24i minus 24i, which is minus a 48i. There's our complex number in number 27, 55 minus 48i. For number 28, there's no parentheses, so we're just going to simply combine those like terms. Combining 3 and negative 4 together, that's going to result in a negative 1. And then combining 7i minus 3i together, that's going to result in a positive 4i. So negative 1 plus 4i is our solution for number 28. For number 29, how are we going to go about doing this? Well, you can see that we have parentheses here, and this 3 needs to be distributed into that complex number, to both the real part and the imaginary part. And over here, we have a negative 3i times a 6i. So I'm going to go ahead and do this multiplication as well at the start, since it's not part of this term that we're going to need to distribute through. So negative 3i times 6i is a negative 18i squared. And we're subtracting this entire quantity. So just to make it a little bit easier, what I'm going to do is I'm going to distribute a negative 3 so that I don't have to worry about my sign later on. So negative 3 times negative 7 is going to be a positive 21, and negative 3 times 6i is going to be minus 18i. Now, we just have to simplify. Negative 18 times I squared is negative 18 times negative 1, which is a positive 18. So we have 18 plus 21 minus 18i. Combining 18 with 21, since those are both real numbers, we're going to get 39, and we need to subtract 18i. There we have it. That's our solution in number 29. Now on to number 30, our last problem for the set of directions that said simplify. And how we're going to simplify this is, well, let's start by taking this negative 6i and distributing it into this first complex number. So distributing it to the real part and the imaginary part. So we have negative 6i times 8i is a negative 48i. And we have negative 6i times a negative 6i, which is going to be a positive 36i squared. And this is all going to be multiplied by negative 8 minus 8i. But let me continue simplifying down this first part, because we know that 36 times I squared is going to be 36 times a negative 1. So I'm going to rewrite this as negative 36. Now let's distribute this complex number to this complex number, one binomial to another. So negative 48i times negative 8 is going to be a positive 384i. Then negative 48i times negative 8i, well, that's going to be a positive 384i squared. Next, negative 36 times negative 8, that's going to be a positive 288. And then finally, negative 36 times negative 8i is going to be a positive 288i. Now we can combine our 384i and our 288i together right at the start. 384 plus 288 is going to result in 672i. So I have my imaginary part as 672i. Now I just need to figure out my real part, which 384i squared is a negative 384. And when I add that negative 384 with a positive 288, I get a negative 96. So we have negative 96 plus 672i as our solution for number 30. Let's move on to our next set of directions. So here we are moving on to these critical thinking questions. We have number 31 and 32, which both ask how the problems are different. So let's think about number 31. The first part has us simplify 2 plus x and 3 minus 2x. The next is to simplify 2 plus I and 3 minus 2i. So it looks like we're going to need to perform the same exact thing for both problems. But remember, there's one extra step we're going to have to do. For our first problem, when we finish out FOILing, doing x times that negative 2x, that's a negative 2x squared as that last term. And we can be done with it because x squared is simply x squared. However, in this final part, when we have I times negative 2i, that's a negative 2i squared. And I squared we know is a negative 1. So we can simplify this bottom problem further. There's an extra step. So we're just going to simply say that I squared equals negative 1. So it's going to lead to a few more steps in our simplification process. Because then once we calculate that negative 1, that becomes a real number, which we can then combine with any other real number and continue to simplify. So that's how these two problems are different for number 31. Let's move on to 32. For number 32, how are these two problems different? Well, let's think about it. 2 plus x minus 3 minus 2x. If I want to remove these parentheses, I would need to just make sure I distribute that negative throughout. So I'm going to simplify this to 2 plus x minus 3 plus 2x. And I'm going to rewrite the next problem below similarly, distributing the subtraction to that complex number. So 2 plus I minus 3 plus 2i. Now what are my next steps? Well, I'll combine the 2 and negative 3 and the x and 2x. And that's the same thing I'm going to do below. I'm going to combine the 2 and negative 3 and the I and 2i. So there is no difference between these two problems. We go through the same exact steps. So there is no difference. And with that final solution, we complete this Infinite Algebra 2 free worksheet. If you have any questions, leave it in the comments below, and I or one of your peers will get back to you as soon as we can. But as always, don't forget to like, subscribe, and share. Happy learning!